So, Max, I was reading about this new AI system that apparently outperformed most human hackers in a real-world penetration test. Wild stuff.
Wait, seriously? An AI system beat human security professionals at their own game? I thought we were still years away from that kind of capability.
That's what I thought too. But this new system called ARTEMIS placed second overall in a head-to-head competition with cybersecurity pros. And get this, it costs way less per hour than hiring human pen testers.
Well, that's either incredibly impressive or slightly terrifying, depending on which side of the security fence you're on.
Welcome to another episode of Totally Unprofessional Peer Review. I'm Casey Park, developer and structure enthusiast.
And I'm Max Stone, your friendly neighborhood theorist with an unhealthy obsession for metrics and methodology.
Today we're diving into a groundbreaking paper that pits AI against humans in the high-stakes world of cybersecurity penetration testing.
That's right. The paper is titled Comparing AI Agents to Cybersecurity Professionals in Real-World Penetration Testing, and it introduces ARTEMIS, a multi-agent framework that apparently gives human hackers a serious run for their money.
The researchers evaluated 10 cybersecurity professionals alongside 6 existing AI agents and their new ARTEMIS system on a massive university network with about 8,000 hosts across 12 subnets.
And the results are honestly surprising. ARTEMIS placed second overall, discovering 9 valid vulnerabilities with an 82% valid submission rate. It outperformed 9 out of 10 human participants.
Plus, it's way cheaper. Some ARTEMIS variants cost just $18 per hour versus $60 per hour for professional penetration testers. That's a pretty compelling business case right there.
But before we start updating our resumes, there are some important limitations. These AI agents had higher false positive rates and struggled with GUI-based tasks that humans find relatively simple.
So the big question is, are we witnessing the beginning of the end for human penetration testers, or is this just another tool that will ultimately augment human capabilities?
And more importantly, what happens when malicious actors start using these same AI techniques to find vulnerabilities before the good guys do?
Let's dive into the details and find out if your next security audit might be conducted by an algorithm instead of a person. So let's talk about what makes ARTEMIS so special. The paper calls it an automated red teaming engine with multi-agent intelligent supervision. That's quite a mouthful.
Love a good acronym in research papers. But beyond the fancy name, ARTEMIS represents a significant advancement in AI-powered security testing. It's not just another chatbot trying to hack things.
Right, and the paper makes it clear that ARTEMIS is specifically designed for long-horizon, complex penetration testing on real-world production systems. That's ambitious.
Let's look at how ARTEMIS is structured. The paper describes it as having 3 core components.
I see from this diagram that it has a supervisor that manages the workflow, a swarm of sub-agents that can work in parallel, and a triager for vulnerability verification. That's a pretty sophisticated architecture.
What's interesting is how the supervisor operates. According to the diagram, it handles a user-specified task and then coordinates everything through what they call an agent action space, writing notes, reading logs, making to-do lists, and even spawning new sub-agents as needed.
And then those sub-agents get custom-tailored instructions through something called dynamic prompt generation. That's pretty clever. Each sub-agent gets task-specific system prompts rather than generic instructions.
The triager component on the right is also crucial. It has 3 phases: initial review, validation and reproduction, and severity classification. This helps reduce false positives, which is a common problem with automated security tools.
One thing that stands out to me is how ARTEMIS handles the context limitation problem that plagues most AI systems. The paper mentions that ARTEMIS operates over extended durations by splitting work into sessions, summarizing progress, clearing context, and resuming where it left off.
That's a critical innovation. Most AI systems hit a wall when they run out of context window space. By summarizing and clearing context periodically, ARTEMIS can theoretically run indefinitely on complex tasks.
Let's take another look at that diagram. What really impresses me is the parallelism. The paper mentions that ARTEMIS reached a peak of 8 active subagents in parallel, averaging 2.82 concurrent sub-agents per supervisor iteration.
That's a huge advantage over human penetration testers. The researchers observed that when ARTEMIS finds something noteworthy from a scan, it immediately launches a subagent to probe that target in the background, sometimes resulting in multiple subagents for multiple targets.
And humans simply can't do that. The paper even mentions a specific example where they observe one participant, note, a vulnerable LDAP server that other participants reported, but that person never returned to investigate it further.
It's important to note that ARTEMIS isn't increasing the underlying AI model's cybersecurity knowledge. The paper specifically states that ARTEMIS does not increase models' cybersecurity knowledge, but enhances execution flow and planning in complex production environments.
So it's more about the architecture and coordination than any breakthrough in security expertise. That makes sense. It's optimizing how the AI approaches these complex tasks.
And they took safety seriously during testing. The paper mentions a dual-layered approach. During our tests, a member of our team observed the agent's trajectories at all times and could terminate the session if necessary, and at the same time, a member of the target's IT department monitored the network's logs and infrastructure.
That's reassuring. The last thing you want is an AI agent going rogue in a production environment. But I'm curious about how ARTEMIS compares to other AI systems for penetration testing.
The researchers compared ARTEMIS to several other systems: OpenAI's Codex, Claude Code, SciAgent, Incalmo, and MAPTA. They specifically excluded semi-autonomous systems like Pentest GPT to focus on fully autonomous capabilities.
And how did these other systems perform compared to ARTEMIS in the study?
The paper mentions that existing scaffolds like Codex and SciAgent underperformed relative to most human participants, while ARTEMIS demonstrated technical sophistication and submission quality comparable to the strongest participants.
So ARTEMIS really does represent a significant step forward in this field. It's not just marginally better than existing systems, it's in a different league entirely.
Exactly. And it's worth noting that this work was supported by the Stanford Institute for Human-Centered Artificial Intelligence seed grant and an unrestricted gift from OpenAI. So there are some serious research institutions behind this.
Now that we understand what ARTEMIS is and how it works, let's dig deeper into how it actually performed against human cybersecurity professionals in those real-world tests.
Let's dive into the actual results of this study. The researchers conducted a head-to-head comparison between human cybersecurity professionals and various AI systems, including their new ARTEMIS framework.
Right, and they recruited 10 cybersecurity professionals through word-of-mouth referrals, calls for participation in cybersecurity communities, and professional organizations. These weren't just random people, they were vetted based on their educational background, industry certifications, and published vulnerability disclosures.
And the testing environment was pretty substantial, a large research university's public and private computer science networks. The scope included 12 subnets, with 7 publicly accessible and 5 accessible only through VPN, covering approximately 8,000 hosts.
That's a massive attack surface. Let's take a look at how everyone performed. This table from the paper shows the participant performance rankings.
This is fascinating. Looking at the table, we can see that ARTEMIS configurations A1 and A2 are mixed right in with the human participants. A2 actually placed second overall with a total score of 95-20, only behind the top human performer P1 who scored 1-on-1-4-4.
And what's really interesting is that both ARTEMIS configurations outperformed most of the human participants. A1 beat 3 humans and A2 beat 9 out of 10 humans. That's pretty remarkable.
I'm also noticing the other AI systems at the far right of the table, CO, CS, and CG, which represent Codex with GPT-5, SciAgent with Claude Sonnet, and SciAgent with GPT-5. They all perform significantly worse than ARTEMIS with total scores in the 20s compared to ARTEMIS's scores in the 50s and 90s.
That really highlights how the scaffold or framework matters just as much as the underlying AI model. The paper specifically mentions that scaffolding is crucial. A1 outperformed 50% of human participants, yet GPT-5 in Codex outperformed only 2 humans, and GPT-5 in SciAgent was outperformed by all others.
Let's talk about the scoring system they used. The researchers developed a unified scoring framework to quantify both the technical sophistication and business impact of submitted vulnerabilities. They actually departed from standard penetration testing doctrine that favors easily exploitable, low-hanging fruit, instead rewarding more technically complex exploits.
That makes sense for a fair comparison. The total score was calculated by summing the technical complexity and weighted criticality of each vulnerability found. This approach rewards both finding a lot of vulnerabilities and finding particularly severe or complex ones.
Let's look at how Artemis performed on a standardized benchmark. This table shows the comparison of success rates on something called Cybench.
Interesting. Artemis achieved a 48.6% success rate, which puts it in second place, only behind Claude 4.5 Sonnet at 55%. It even outperformed OpenAI's GPT-5, which got 45.9%.
Now let's look at the distribution of vulnerabilities by severity. This figure shows how each participant and Artemis performed in terms of finding vulnerabilities of different severity levels.
This is revealing. You can see that A1 and A2, the two Artemis configurations, are on the right side of the chart. A2 in particular found a good mix of critical, high, medium, and low severity vulnerabilities. But I'm also noticing that A1 had more false positives than most human participants.
That's a good catch. The paper specifically mentions that Artemis is more prone to false positives than humans. For example, it falsely reported successful authentication with default credentials after receiving 200 OK HTTP responses, but these were actually redirects to the login page after failed logins.
Right, and that kind of interaction flow is trivial for humans operating with a GUI, but it's harder for AI systems to interpret correctly.
Let's look at how findings accumulated over time. This graph shows the number of valid participant findings as the test progressed.
This is fascinating. You can see the two Artemis configurations in red, A1 and A2. What's notable is that Artemis typically has more time in between submissions than humans, which the researchers suggest demonstrates impressive long horizon performance.
And look at the top performers. P1 and P4 found 13 vulnerabilities each, while P2 found 8 and Artemis A2 found 9. The paper mentions that the top human performers balanced automated scanning with thorough manual analysis, while weaker performers relied too heavily on automated tools without validating their results.
So in some ways, the humans who performed best were those who worked most like ARTEMIS, systematic and thorough, but also able to validate and analyze their findings.
The researchers also did an interesting follow-up experiment. They wanted to see if Artemis could find specific vulnerabilities that humans discovered, but Artemis initially missed. So they tasked Artemis with finding these vulnerabilities using different levels of hints.
This table shows whether Artemis found the target vulnerability with different levels of hints. For example, with high hints, it successfully found email spoofing, SQL injection, and stored XSS vulnerabilities. But it struggled with the unauthenticated remote console vulnerability, even with high hints.
What's interesting is that Artemis could find some vulnerabilities with very minimal information, like email spoofing even with low hints, and the unauthenticated remote console with just the host information.
Let's talk about some of the key differences between how humans and Artemis approach penetration testing. One major advantage Artemis has is parallelism. It can launch multiple sub-agents simultaneously to investigate different targets.
Right. The paper specifically mentions an example where they observed one participant, P2, note a vulnerable LDAP server that other participants reported, but P2 never returned to investigate it further. Artemis doesn't have that problem. It can pursue multiple leads at once.
On the flip side, Artemis has some limitations. The paper mentions that it struggles with GUI-based interactions. While 80% of human participants found a remote code execution vulnerability on a Windows machine accessible via TinyPilot, Artemis had trouble with the GUI-based interaction required.
There's also an interesting difference in approach. Top human participants are more likely to pivot or deepen their foothold after finding a vulnerability, whereas Artemis tends to submit findings immediately and move on, sometimes missing deeper vulnerabilities as a result.
For example, the paper mentions that Artemis found a CORS vulnerability in TinyPilot but missed the more critical remote code execution vulnerability by moving on too quickly.
But Artemis also has some advantages when it comes to certain technical tasks. The paper mentions that 60% of participants found a vulnerability in an IDRAC server with a modern web interface. However, no humans found the same vulnerability in an older IDRAC server with an outdated HTTPS cipher suite that modern browsers refuse to load.
And Artemis successfully exploited this older server using curl K to bypass SSL certificate verification, while humans gave up when their browsers failed. That's a great example of how Artemis can excel at tasks that involve parsing code like input and output, especially when GUIs are unavailable or problematic.
So to summarize the comparative performance, Artemis placed second overall, discovering 9 valid vulnerabilities with an 82% valid submission rate, outperforming 9 out of 10 human participants. That's pretty remarkable for an AI system.
And while existing AI frameworks like Codex and SciAgent underperformed relative to most human participants, Artemis demonstrated technical sophistication and submission quality comparable to the strongest human participants.
The results really highlight both the impressive capabilities of AI systems like Artemis in cybersecurity testing and their current limitations. They're great at systematic enumeration and parallel exploitation, but they still struggle with GUI-based tasks and have higher false positive rates than humans.
It seems like we're at an interesting inflection point where AI systems are becoming genuinely competitive with human cybersecurity professionals in certain aspects of penetration testing, but they're not quite ready to replace humans entirely.
Exactly. And that brings us to our next section, where we'll discuss the future implications of these findings for the cybersecurity industry.
So we've seen that Artemis performed impressively against human cybersecurity professionals. But I think what really caught my eye in this study was the cost comparison. The paper makes a compelling economic case for AI penetration testing.
Absolutely. According to the paper, cost is a major differentiator between AI agents and human professionals. They ran Artemis for a total of 16 hours, 8 hours across 2 working days, from 9 a.m. to 5 p.m., and carefully tracked the costs using dedicated API keys.
And the numbers are pretty striking. The API configuration of Artemis cost just $291.47 for those 16 hours, which breaks down to $18.21 per hour. If you extrapolate that to a full-time equivalent, that's about $37,876 per year.
While the H configuration, which used more advanced models, cost $944.07, or about $59 per hour, equivalent to $122,720 per year. But even that higher-end configuration is competitive with human penetration testers, who earn an average of $125,034 per year in the US, according to the paper.
And remember, the participants in this study were each compensated $2,000 flat rate for their time. That's a significant upfront cost compared to pay-as-you-go AI systems.
What's really interesting is that the A-PHY configuration achieved similar vulnerability counts to A-PHY at roughly a quarter of the cost. So there's a clear cost-to-performance ratio advantage even among different AI configurations.
The paper also breaks down where those costs came from. In decreasing order, the biggest contributors were the subagents, then the supervisor, and finally the triage module. That makes sense given how Artemis works with multiple parallel agents.
There's another cost advantage that's more subtle but equally important. The paper mentions that most other AI agent systems like Codex signaled completion early, under 20 minutes in some cases, or just under 2 hours for SciAgent.
Right, whereas Artemis was designed for long horizon performance and ran for the full testing period. That's crucial for real-world penetration testing, where thoroughness matters more than speed.
But cost is just one factor. Let's talk about the technical limitations of AI penetration testing agents that the paper identified. The most significant one seems to be their inability to interact with graphical user interfaces.
That's a major bottleneck. The paper specifically mentions that 80% of human participants found a remote code execution vulnerability on a Windows machine that was accessible via a GUI interface called TinyPilot. But Artemis struggled with that interaction.
The researchers do note that advancements in computer use agents should mitigate many of these bottlenecks in the future, but for now, it's a significant limitation.
Another limitation is the higher false positive rate. Artemis and other AI agents were more likely than humans to report vulnerabilities that turned out not to be valid.
Right. Like the example they gave where Artemis falsely reported successful authentication with default credentials after receiving 200 OK's HTTP responses, which were actually redirects to the login page after failed login attempts.
That kind of nuanced understanding of web application flow is something humans pick up easily through visual feedback, but it's harder for AI systems to interpret correctly.
The paper also mentions that other AI scaffolds primarily submit scanner-type vulnerabilities that are gated by network enumeration, occasionally requiring one additional step like confirming anonymous access. Beyond that, these agents lose high-level perspective and perform only surface-level tasks.
Whereas Artemis was able to find and exploit vulnerabilities requiring higher technical complexity. That's a significant advancement, but there's still room for improvement.
Let's shift gears and talk about the broader implications of this research. The paper raises some important concerns about the risks AI poses to global cybersecurity.
Yes, they cite several sources suggesting that threat actors ranging from nation-states to financially motivated groups are beginning to leverage AI in their cyber operations. That's a concerning trend.
It creates a sort of arms race situation. If defensive tools like Artemis become widely available and the researchers mention they're open sourcing it, then both defenders and attackers will have access to similar capabilities.
That's the double-edged sword of security research. By making these tools available to defenders, you're also potentially making them available to attackers. But generally, the security community believes that openness ultimately benefits defense more than offense.
And there's a strong case to be made that open sourcing Artemis is the right move. It helps level the playing field for smaller organizations that can't afford full-time security teams or expensive penetration testing services.
Exactly. If a small business can run Artemis for 18 per hour instead of hiring a penetration tester at 60 plus per hour, that makes good security practices more accessible.
The researchers also outline some interesting directions for future work. They mention creating runnable environment replicas for longer-term replicable evaluations, as well as testing different agent architectures, configurations, and models.
They also plan to enhance participant infrastructure for more accurate event capture, collaborate with vendors on bug bounty programs, and extend their logging framework to integrate with defensive tools like SIEM systems.
All that suggests they're thinking about how to make AI penetration testing more robust, more integrated with existing security workflows, and more useful for real-world applications.
So, what's your takeaway, Max? Are AI agents going to replace human penetration testers in the near future?
I think the paper makes it clear that we're not quite there yet. AI agents like Artemis have impressive capabilities and cost advantages, but they still have limitations that human testers don't, particularly around GUI interactions and contextual understanding.
So, more of an augmentation than a replacement, at least for now?
Exactly. I can see organizations using systems like Artemis for continuous, systematic testing to find the low-hanging fruit and more obvious vulnerabilities, while bringing in human experts for more complex assessments or when GUI interactions are required.
That makes sense. And as the researchers continue to improve these systems and address their limitations, the balance might shift further toward automation.
One thing's for sure, the economics are compelling. If you can get comparable results at a fraction of the cost, that's going to drive adoption regardless of the current limitations.
And that could ultimately be a good thing for cybersecurity as a whole. If more organizations can afford thorough penetration testing, we might see a general improvement in security practices across the board.
That's a great point. Democratizing access to sophisticated security testing could raise the baseline security level for everyone.
Though I do worry about the potential for misuse. As these tools become more sophisticated and accessible, they could also be used by malicious actors to find vulnerabilities before defenders do.
That's always the risk with security tools. But I think the researchers are taking a responsible approach by focusing on how to integrate these AI systems with existing security workflows and defensive tools.
And by being transparent about both the capabilities and limitations of systems like Artemis. That helps organizations make informed decisions about how to incorporate AI into their security practices.
Ultimately, this paper represents an important milestone in the evolution of AI-powered cybersecurity tools. Artemis may not be perfect, but it demonstrates that AI agents can now compete with human professionals in certain aspects of penetration testing.
And at a fraction of the cost, which is no small consideration for organizations with limited security budgets.
The future of cybersecurity is likely to involve a collaboration between human experts and AI systems like Artemis, each bringing their unique strengths to the table.
That's a future I can get behind. Now, let's wrap up our discussion and summarize what we've learned from this groundbreaking research.
Well, Casey, this research really shows we're at an inflection point in cybersecurity. Artemis outperforming 9 out of 10 human professionals at a fraction of the cost is both impressive and slightly unnerving for those of us who value job security.
Absolutely, Max. While Artemis still struggles with GUI interactions and has a higher false positive rate, it's clear that AI-powered penetration testing is no longer science fiction. Organizations that embrace these tools will likely see improved security postures without breaking the bank.
I think the key takeaway is that the future isn't about AI versus humans, but AI with humans. The most effective security teams will leverage both automated systems like Artemis for systematic testing and human expertise for nuanced analysis.
That's right. And as these systems continue to evolve, we'll need to stay vigilant about both their capabilities and limitations. Thanks for joining us for another episode of Totally Unprofessional Peer Review.
And remember, folks, in the world of cybersecurity, the only thing more dangerous than an AI that can hack your system is a human who knows how to use it.